who here has played Blackjack? Just so I can get, or who here, better yet, hasn't? Okay, then I'll talk a little slower for you guys. But yeah, so all you need in the equation is a mathematician and a little curiosity, and you're wondering the same thing Thorp did. So I'll read the quote. I was behind a total of 8.5 silver dollars and decided to stop. But the atmosphere of ignorance and superstition that pervaded my little experience securely planted in my mind the suggestion that even good players didn't know the fundamentals of the game. There might be a way to beat it. So roughly go through my outline. First I'm going to talk about an introduction before we get into the rules, like why Blackjack is an interesting game to analyze. I'm going to go over the rules quickly, try and make that as quickly as possible, and then I'm going to get to the mathematics behind some of the rules like splitting and insurance. And then I'm going to go over some of the old strategies that were kind of common, like through superstition before analysis. And then I'll talk about the new strategies that Thorp came up with and provide two endgame scenarios where Thorp actually used the examples to gain money. So, okay. So first I want to talk about the property of memory. So as Epstein states, there is no betting scheme that can be devised that will have the slightest effect on the casino's long-run advantage. And that's mostly true. The most popular one that you'll know, probably, is the small martingale system. So to demonstrate, I'll just explain how that works. So how that works is you have an initial bet. So you start off with your initial bet. If you win, we'll say that's 1 unit. If you win, you take your winnings, and then you start off with the initial bet again. If you lose, Brian?
Is it called doubling down otherwise, or?
No, doubling down is actually something in Blackjack. This is a betting system that is based off the gambler's fallacy, which I'll talk about later too. So what I'm talking about is a small martingale system. You can look it up later. But this is what it is. So if you win, you take back your earnings. If you lose, then the next bet you do is twice what you last bet. So that if you win again, your net loss is now 0. Of course, so that's for independent probability events, and that's based on the gambler's fallacy, which is that if you have these repeated independent probability events, and you see deviations from expected behavior on one side, then future deviations are more likely to occur on the other side, which is obviously false. So consider what makes Blackjack such an interesting game is the property of memory. So it's much different than coins. The cards actually have memory to them. And what that means is, as the deck keeps expiring, each card that shows up affects the probability of the game. Now, before Thorp published his book and changed the rules of the game was played with one deck, so 52 cards, and played until the last card. And the last card would be discarded. So, I also wanted to touch on the fact that the small martingale system, it doesn't work. It's proved through theory that if you have an infinite capital, you will gain a small problem profit. But what stops that is the maximum bet in casinos. So say you have a maximum bet of $500 in a casino. So if you lose 9 times in a row, you lose $1, then $2, all the way till 256. Your next bet, you can't bet 512. So that's the flaw with this system. Okay? But what Thorp realized was that because the game has memory and it plays till the end of the deck, the number of positive expectations throughout the game and the number of negative expectations throughout the game stays constant. But what can vary is the distribution of your bets. So if you're in the red, you'll bet your minimum bet, and when the game is favoring you in terms of probability, you increase your bet. And so thus he created a betting system that not only created profits but maximized them. So I'll talk a little bit about the origin of the game. It originates from the game 21, and the specified date of inception is unknown. And where the name Blackjack actually came from is the name of the payout if you got an initial 2-card pairing of ace of spades and either of the blackjacks. But it was soon discontinued because of the player advantage of game. But since the game's popularity, the momentum was still going, the name stuck. And of course, I'm going to touch on whether this is a game theory game. So a game, in terms of game theory, is defined as a conflict between people or groups of people that can be resolved through some form of intelligence, bounded by a set of rules and conventions, distinguished by contending interests, value of the winning payment, number of moves required, and amount of information available. This sounds a lot like the Blackjack for those of you who are familiar with the game, but by by definition, it's not game theoretic because the dealer, who counts as a player, has a fixed strategy, which I'll detail later as well. So just a few given before I get into the rules. We assume that it's important to note that, yeah, like I said before, I'm gonna talk about the rules in context before the changes were made due to Thorp's book, so that the endgame scenarios actually make sense at the end. So we'll say for now we'll cap the limit as 6 players participate in the game. Cards are dealt left to the dealer to each of the M players until everybody holds 2 cards, and then if say me, Arthur, and Sherry are playing, then Arthur makes his play, and then until he decides to stand. Similarly with Sherry, then I as the dealer play. And the aim is to beat the dealer's total while keeping your total less than or equal to 21. So each card assigned 2 to 10 is assigned a numerical value equivalent to its rank. Face cards hold a value of 10 as well, and aces can be either 1 or 11 at the player's discretion. But for the dealer, it has to count as 11 if it brings it the total in between 17 and 21, otherwise it counts as a 1. And so for now, I'm going to refer to the pairing of an ace and a 10 as a natural, just to not confuse it with the name of the actual game. And so a natural is the winning combination. So 3 cases occur. The first case is when the player has a natural and the dealer doesn't. The player receives a 3-2 payout, which is important to increasing its odds in the game. The dealer has a natural and the player doesn't, and then the dealer wins the amount wagered because of the order of play. If the dealer has a natural and the player doesn't, then the dealer wins. And if the dealer and the player receiving a natural, then it comprises a tie. And insurance is a bet where if the dealer's face-up card is an ace, the player is presented with an option to wager a maximum of 1/2 the original stake that the whole card is valued 10. So basically you're betting that the dealer has a blackjack. The payout is 2 to 1 if the dealer has a natural, so although you lose your hand because he has a natural, the insurance bet earns back the loss for a net loss of 0. And if the dealer's whole card is of a different value, then insurance is lost, card remains face down, player resumes as normal. And what splitting is if your initial 2 cards comprise a pair of something, say you have 2 sevens, you're afforded the option to split the 2 cards into 2 independent hands. So if I receive 2 sevens and I choose to split, the original bet backs my first hand, and then I have to double my bet to back the second hand. And the 2 hands act as independent hands. And a special case is if a pair of aces are split, then any value of 10 drawn counts as a normal 21 rather than a natural, and may receive only 1 card per ace. And doubling down, you're afforded the option to double down if immediately after you receive your 2 cards, you can choose to double your original stake and draw only 1 more card, so nothing more. Okay, I'm going to talk about the dealer's fixed strategy. So how the dealer plays is, if the dealer's total is 16 or less, he has to hit and receive another card. If the total is in between the range of 17 and 21, he has to stick with his current hand. And if his hand includes an ace, it must be counted as an 11, like I said, if it brings it to 17 or 21, otherwise it counts as a 1. And the dealer will never split or double down. Okay, so what is basic strategy? For those of you who have played, you've probably heard it. Basic strategy is the best possible strategy you can play with, not considering the memory part of the game. So really it's just a bunch of charts based on what you have and what the dealer has. So there's 55 distinct initial 2-card combinations that you or the dealer can receive, and the dealer's face-up cards value can range between 2 and 11. So the strategy is just spanned by decision trees of each of the 550 distinct possible unique cases on whether you should draw, stick, split, or double down. Okay, so sorry, the variables seem to be a little off. But so we're gonna define T naught as the 2-card total we hold, and we're gonna define tau as the total the dealer has. It didn't fit on the slide. I'll just try to work around it. Okay, so like I said, the basic strategy is created upon just the dealer obtaining between 17 and 21, and the different probabilities of us obtaining various totals. So we define the probability of winning as here. So we define the probability of winning as the probability that our initial 2-card hand total is better than the dealer's, and or define our probability of tying as if our card totals match up. And we define the player's probability of losing as if the dealer beats our total but stays within 21. Okay, so knowing that the probability of winning, tying, and losing is equal to 1, we can define our mathematical expectation as a function of our total, given by the probability of us winning minus us losing. We make the substitution, and we use the substitution from the previous slide as well. And then now we can define a new variable t sub 1 to be the total obtained if we draw one additional card. So now our probabilities change a little. Now our probability of winning is the probability of us beating the dealer but within staying 21, because if we draw we might bust. And the probability of the dealer busting whilst us staying 21. The probability of us tying is now us tying while both of us staying 21. And the probability of us losing is the dealer beating us while staying under 21 or us busting. So now we have a mathematical expectation for our new total if we draw one card, shown as there. So now the decision to whether we draw is simply broken down into whether the expectation of us drawing a single card is greater than us sticking on our initial 2-card hand. And also, another decision is made. If t sub 1 is smaller than 21, then again, we have a decision to make. We need to decide whether we should draw again. Continued iteration leads to expected value of our t sub I plus 1 minus expected value of t sub I. And there will be a point where this difference will be negative, which means that it's better for us to stick. And so this sticking point, the sticking value, will be denoted t star. And that's how we fill up our decision trees. So similar logic can find the decision equation for soft totals, doubling down and splitting. And so now we'll analyze the decision to split. So we'll define the star expectation of T naught as a mathematical expectation of beginning with T naught, a hard total of T naught, and if we follow the basic strategy, including doubling down. The decision on whether to split simply becomes whether twice the expectation of our total divided by 2 is greater than if we just played with the regular, value. And so 2 cardinal rules arise just looking at this formula. So the first is to always split a pair of aces, because we have a higher chance of winning if we're playing with 2 hands starting with an ace than if we were to draw, stick, split, or stand on a soft 12. And we will always split a pair of 8s given that the dealer has a 7 or higher, but for a different reason. Not because splitting the 8s gives us a better chance of beating the dealer's hand, but because if the dealer has a 7 or a higher, because the 10 has the most cards in the deck is of a value 10, the dealer has a good chance of not busting. And you have to consider that the dealer will keep hitting until he gets higher than 16. So if we have a 16, the dealer will keep hitting until he can beat us. And so we're splitting a bad hand into 2 average ones. And the decision to ensure, there's been a lot of commentary on how funny the name is, because the name insurance implies that if you have a really good hand, like 2 10s, that you'd rather insure that than having, say, like a 2 and a 5. But really what the decision comes down to is not the total, but the composition of your hand. So the equation is the number of your 10s in your deck minus the total cards you start with, number of 10s in your deck divided by total cards you started with minus the cards you observe. And if that's greater than a third, you'll accept the insurance bet. So what I mean by composition of hands matters, if you have 2 10s, you're probably not going to insure because you know that those 2 10s can't be the whole card that the dealer is holding. But if you have a 2, 3, 4, 5, 6, and you're totaling 20 with that hand, that makes this number greater, which makes your probability higher, which would make you want to accept. So now I'm just going to get back to... Okay, so I also want to talk about the most important card in the game, because a lot of the common misconception is that the most important card in the game is the ace, but really it's not the ace or the 10. If you're considering just the card itself, the most important card in the game is the 5. And that's where Thorp started his strategy. So he started by card counting the 5s. And this was found by seeing the expectations of you winning the game with each card removed. So he removed all the aces in the deck, looked at the probabilities, removed all the 5s, found out that the 5s, if you removed, gave you the biggest difference. But he moved on to a 10 count because there's simply 4 times as many 5s as, there's four times as many 5s. And so some of the conventional old strategies was to stop at a hard 12, which is called never busting. So if you, the old thought process was that if you remove your probability of busting, you have a higher chance of winning. And another one was to mimic the dealer. So if the dealer always beats you all the time, why not just copy how he's going to play? And I'm going to look at the ladder. So if we mimic the dealer, just to remind you guys, we'll draw to 16 or less, stand on 17 or more, never double down, split pairs, or take insurance. And you'll find that the game is symmetric except for 2 situations. So the first situation is if both of us bust our hands, and the second is if one of us has a natural and the other doesn't, and vice versa. So it's been found later that the house has an edge of 5.7 if you choose this strategy, which is much worse than if you just played with basic strategy. So to do this analysis, we're going to have to make an assumption. So we're going to assume stochastic independence, which according to Epstein creates a pessimistic evaluation of the game expectation by 0.003. And so in the first scenario where we both bust, the dealer would win in this scenario because of order of play. All the players have to finish their hand before the dealer starts. So the probability of the dealer busting is 0.236. So assuming that the stochastic independence, we can just borrow that probability for ourselves because we're playing like a dealer. And so the probability of both of us busting is that figure times itself times 100, which is 8.04. And the second scenario where one of us has a blackjack and the other doesn't, we win 1.5 units, whereas the dealer just wins 1 unit. So we take the difference in the units won, and we times that by the probability of getting a blackjack if you play like the dealer, and that gives us an advantage of 2.34. So if you minus 8.04 and 2.34, you get the 5.7 that I referred to earlier. Okay, and so before I get to those examples of the anecdotes that Thorp laid out in his book, I'm going to talk about something called end-play. So like I said before the book was published, how the game worked was that you would let the game conclude all the way to the last card, and then you discard the last card, which makes sense, like to let the game resolve itself. But I'll show you exactly why the card counting took advantage of this so much. Okay, so consider a scenario where you're playing as Thorp, okay? And you know that there's about 6 cards left. So we're going to be playing with the modified simple point count. That's counting 2s and every card with rank 2s and 6s, 2s till 6s as +1. 7s to 8s don't add to the count, and 9s to 11s give the count -1. And this is called a running count. So with how we assign each of these cards with these values, that starts our running count at -4. If I see a 3, my running count is now -3. If I see an 8, my running count stays the same. If I see an ace, then my running count is now back to -4. So in this scenario, we know that there's 6 cards left, and our running count is still -4. So that means there's only 7s and 8s left, and we know that. And if our memory and skills is sharp as Thorp's, it's reasonable to assume that we've seen at least 2 7s. So these are the possible hands that the dealer can get. 2 7s, an 8 and a 7, or an 8 and an 8. So if you're playing a basic strategy, you're definitely guaranteed to lose, and I'll show you why later. And if you're playing as a card counter as Thorp, then you're even borrowing money from your friends if you don't have enough, because it's guaranteed to win. So basic strategy says that if you have less than a 17, and you're facing a 7 or higher, then it advises you to always hit. But of course, since there's at most two sevens, even if you had the 7 and a 7, you would bust. So if you're the card counter, you would just sit back happily, stand on whatever hand you got, and watch as the dealer busts, because 1, 2, and 3 are all smaller than or equal to 16. Therefore, by rule, the dealer must draw. And the second scenario is one where Thorp details him perfecting his 10 count. And what the 10 count is simply just counting the cards in terms of tens and others, and keeping a ratio in your head called the 10 richest ratio. Now, Thorp doesn't actually detail how many players he was playing with or what their cards were, but he gives me enough information for me to paint a picture for the sake of the story. So we'll say we're playing with 2 other players who are playing with basic strategy. And we'll say that first player gets a 6, second player gets a jack, and we get an 8. The dealer gets a 10, a queen. Second player gets a 4, and so on. Okay, so as you can see from the totals, we'll say that the first player, by basic strategy, he's obviously going to hit. He has a 10, he has nothing to lose. He gets a 17, he's happy, he stands. The second player similarly has a 19, he's happy, he stands. So once this player stands, and also for the sake of the story, Thorp said that he knew what the other players were holding because he was peeking. So we'll assume we're right there with them and that we're peeking as well. But at this point, there's 2 cards left unknown for play. There's the dealer's hold card, and there's 1 more card left in the deck. And since he's counting tens and others, and all his others are counted up, he knows that the last 2 cards are tens. So he knows that even though he's holding a very solid hand, an 18, he's not going to win. And since we're still playing with the fact of end play, the fact that we played to the last card, he knows that if he hits, that 10 is not going to show up. So he asks to hit, which is obviously very unconventional. If you have an 18, drew a lot of attention. So as he expected, it was a 10, but it gets discarded. And as the story goes, he was lucky enough to get a 3. Okay, so that was my presentation. I hope you guys enjoyed it. It wasn't to encourage card counting by any means. It was more, just as Epstein would say, we would rather lose intelligently than win ignorantly.